Let's open SOLIDWORKS and create a 3D part. After done creating 3D part, select on SOLIDWORKS CAM on the toolbar. Then you need to define the machine. In this case we use 3-axis CNC milling machine. So, select on the mill option and choose medium duty, and press OK. In the coordinate system, select the stock bounding vertex option. This will set the selected point as the origin of your workpiece. Then for the stock manager, you can change the size of your stock to match your desired stock material on each direction X, Y, and Z. After this, click on Setup option and select Mill Setup, then select on the top surface. This will help define the orientation of the workpiece within the machining environment. Then we need to define some operation for the machine. First I will working on the big slot on the middle of the workpiece. Right-click on the mill part setup 1 and select the 2.5-axis mill operations and choose Rough Mill. On the 2.5-axis features select Type Pocket. And then select on the slot entities, in our case is Sketch 2. Then click on the End Condition. After this we need to define the depth of milling that we just created. For my case, I extruded cut the slot with the department of 3 mm. So, in the End Condition direction 1, I need to change the depth to 3 mm. Then we will see that the operation is created by the software. Then right-click on it and click Generate Operations Plan. We will get to operations. One is Rough Mill and another one is Contour Mill. I will change the diameter of the tool to 3 mm. For creating this part we will use only one end mill, and edit the 3 mm flat end mill. Then we need to click on the Change option on the pop-up message. Then we need to right-click on each operation and select Generate Toolpath. And after this you can simulate the toolpath of each operation. And now we need to create another operation to drill the 4 holes on our workpiece. Select and right-click on the mill part setup 1, then choose to 0.5 axis mill operations and select on the rough mill. Choose the TO3 end mill, and go the feature, then select Create Feature. Choose the 2.5 axis feature. We need to select on the 4 holes on our workpiece, and for 2.5 axis feature choose the type pocket. We should note that we cannot choose the open pocket operation type for our holes. Then click on the end condition and define the depth of milling on this operation. After this, we will get a new operation on our workpiece. Then we need to generate its toolpath. The same as before, we can simulate the toolpath of this operation to observe the quality of milling. In the simulation, we can see that the surface of our holes is not properly milled. So, we need to create another finish operation for those holes. We need to create another operations for our holes. We can create it the same way as the last operation that we created. But we must change one thing. It is the strategy of operation. We need to change it from the default option, which is rough, to rough and finish to the finish one. This will provide a better holes quality for our workpieces. And in operation parameters, don't forget to change the side parameters allowance to 0 mm. Then we can generate and simulate its toolpath. Now we get better finished holes for our workpiece. We haven't finished our work yet. We need to create one last operation for our workpiece. It is the contour mill. This operation will create the side shape of our workpiece and disconnect our workpiece out of its stock material. To create this operation, right-click on the mill part setup and select onto 0.5 axis mill operation, then choose contour mill. In features for the contour mill, choose part perimeter mill. After this, we can generate the toolpath and observe its simulation. One thing to remember is to create the tab cutting for our workpiece. Tabs will help hold our workpiece securely in place within the stock material, preventing it from becoming dislodged or moving during machining. You can adjust the number of tabs, thickness, and size of tabs in tab cutting setting. Now we can simulate its overall operation. And I'll show you how to get G-code to use with CNC machine. To get G-code, we just need to select on Post-Process button on the toolbar and save it in your desired directory. Thanks for watching.